Okay, 1-4, day 2. Let's review those 6 trig functions again. We really got to hammer these down. So remember, our angle is going to be a rotation from the origin. The amount that it rotates is going to be called theta. And all we need is any point we can find on this ray so we can make a triangle. It's nice if we can get it on the unit circle so it's exactly one away, but we don't have to have that. So any point on here will allow us to find our 6 trig values. Because once we have that ordered pair, you're going to make your right triangle. The x value gives you your horizontal side. Your y value gives you your vertical. And if this point is not on the unit circle, we do have a distance there that's not 1. So we call it r, and we'll actually put it into our ratios. Okay, so sine, standing at theta, go back to my pen. Standing at theta, think of SOH, S-O-H. Opposite over hypotenuse, what 2 sides will that be? Well, let's go. Thomas. Standing here, opposite over hypotenuse will be? Y over R. Again, sine's always attached to the y. Cosine. The ka, you can think of it, but we want to get used to the x, y, and r definitions. Brody? X over r. And then tangent, same thing as the worksheet. Allie? Y over x. And then we had our reciprocal functions. We did practice those on Friday, but do you remember the names that go with those reciprocal functions? Lexi? Last one's the easy one. Attach this one. Cotangent. So we had cotangent. And she did get secant and cosecant. How were they paired up again? Do you remember what I told you? Yeah. Yes, you need an S function with a C function. So sine starts with S, so the cosecant one, starting with the C, goes with the sine. And again, they're reciprocal, so you just go R over Y. And then secant will go with the one that's cosine, because that starts with C. The next one starts with S. R over X. And then we got Y over X. Okay, so we're going to spend a lot of time on these 6 trig functions so that the rest of the book we actually do some applications using why do we learn all this stuff? You're going to see it, but we're just going to practice the heck out of getting these ratios down pat. So find all 6 trig values for the angle passing through let's go -3, 4. So again, when it wants trig values, you need a triangle. Adam?
I was just wondering, for the cotangent, choose the x over y.
Oh. Yes. Thank you. Then flip it over. X over y. All right. Here we go. So we got to plot the point -3, 4. 1, 2, 3. So our angle theta rotated always from the positive x-axis over to this ray that passes through that given point. Okay, in order to get the six trig values, we don't want sigs, those are bad. You're going to make your right triangle. Always connect back to the x-axis. At least someone smiled at that. Always connect back to the x. Even though the angle is outside of the triangle, this is the reference triangle that gives us all of the ratios for that angle. Okay? And we do know that trig values come up negative. So our adjacent side, our x is going to be -3. Our y is going to be 4. Is this point on the unit circle, is this hypotenuse equal to 1? And I can just ignore it? No. Definitely going to be bigger than that. So we do have to figure out that r value. We're not on the unit circle like we were Friday, so we're going to be using the r value in our definitions. So, anybody know what this is going to turn out to be, that distance, Adam?
Well, can you do the Pythagorean?
You can do Pythagorean theorem. So we've got, and again, r is always going to be positive. That's never ever a negative. So we don't have to worry about this negative here. 3 squared plus 4 squared equals r squared. Anybody know what this one is? What triangle is this? The most common right triangle out there? 3, 4, 5. You see the 3, 4 on the legs, you just go ahead and put the 5 down. You don't have to go through all this mumbo jumbo here. So we got an r value of 5. And we got 6 answers to give. Sine, cosine, tangent, cosecant, secant, cotangent. If you want, you can put your x, y, r, or you can just pretend you're standing at the origin and do SOHCAHTOA. It all matches up. So let's have Erica run through the sine, cosine, and tangent for us. What do you think sine's going to be? Yep, opposite over hypotenuse, y over r. Keep going. Yep, the x over r, or adjacent over hypotenuse, -3 over 5. And then the tangent. 4 over -3. Okay, does the 3 have to stay in the bottom here? Because it's attached to the 3 here. The answer is no, because these are ratios. The ratio is what's negative. Yes, the 3 can be in the bottom. The negative can float to the top. It's still the same, or it can be right in line with the fraction bar. So there's 3 ways to write that correctly. All 3 of those are correct, because it's the ratio that we care about. Typically, we write the negative in the top. We always float the negative to the top and say it's a negative ratio. Now flip them over and you're good. So we got 5/4. I'm going to keep the negative in the top and make it a -5/3 ratio, and then -3/4. Easy peasy. They don't get any easier than that one. Something that's going to come up is rationalizing the denominator. So if I had 3 over 2 square root of 3, could you leave an answer like that in advanced algebra or geometry? No. What's wrong with it? What part of it's bad or not? Math gods frown on. You cannot leave a square root in the denominator. And we take care of it. The process is called rationalize the denominator. What did I call it? You remember? Hit it with a 1. Remember that? Hit it with a 1. Okay, I say hit it with a 1 because we're going to multiply this fraction by 1. What happens when you multiply any number by 1? Stays the same, right? Well, what's going to rationalize the square root of 3 is another square root of 3. So anytime you take a number and divide it by itself, it's equal to 1. So all I'm doing is multiplying this fraction by 1. Keeping its value the same, just going to change what it looks like. So I call hit it with a 1. So now you multiply. The top's just going to stay 3 times the square root of 3. I'm going to go baby steps here. I've got 2 times the square root of 3 times the square root of 3. Well, if that 2 wasn't there, what's square root of 3 times square root of 3 turn into? It would be square root of 9. What does square root of 9 turn into? A 3. But I do have a 2 down there. 6. So I'm going to go baby steps. 2 times square root of 9. And then you can skip the baby steps when it comes time for homework. That's 2 times 3. Now is there anything I can do? Adam.
5, 7, 3 and 6.
Which 3? The one underneath or the one out in front?
The one up.
The one out in front. 1, 2. So I would not expect you to show every single step in there. I just wanted to show you all the little baby steps so I didn't lose anybody. Okay, so now something a little tougher. Find all 6 ratios if the angle passes through the point -1, negative square root of 3. So which quadrant is my angle theta passing through? Where is negative at? Third quadrant. So -1. And then negative square root of 3 is like negative 1.7-ish. So I'll go right about there. So about here. So our angle that we're finding all 6 ratios for started here and then rotated into the third quadrant. If we want all 6 ratios, we need a triangle. Always make your triangle back to the x-axis. I'll see people do it to the y-axis. It's not quite right. Don't do that. Always back to the x. Put your values on. Our x is a -1. Our y is a negative square root of 3. We do have to do Pythagorean theorem because we're not on the unit circle. I know it's not going to equal 1. So a little Pythagit. 1 squared plus square root of 3 squared equals our value of r squared. I throw away the negatives because anytime I square, it's going to come out positive anyway. So our r value is 2. So our point is actually 2 units away from the origin. Okay. X, Y, R. Now it's all 6 ratios. Go ahead, write those 3 ratios down on your own. Caden, what'd you get for sine?
Negative square root of 3 over 2.
Perfect. Keep going with cosine.
Negative 1 over 2.
And tangent.
Square root of 3.
Simplified that is, because you've got negative square root of 3 divided by negative 1. The negatives go down to a positive, dividing by 1. Okay. Now let's reciprocal all of those and name them correctly. I'll take you through the first one. Flipping this over, leaving the negative in the top, which is where it typically is written, I get negative 2 over square root of 3. Problem, because that square root's in the bottom, so we hit it with a 1. And you don't have to show this step once you get the hang of this. You can just rationalize your denominator right off the bat. So I can see my rationalized answer will be negative 2 square root of 3 all over 3. Okay, flipping over negative 1/2, just negative 2. Now I've got to go back and see the 1 underneath here so that I can flip it over. This becomes 1 over square root of 3, which needs to be rationalized again. Okay. So your whole assignment is going to be giving all 6 trig values, so the whole point is to find the ordered pair, make your triangle. Well, the next one I'm not going to give you the point. Can I get rid of this? Find all 6 values. If the terminal side, remember that's where it stops, it terminates the rotation. If the terminal side of the angle is the line negative 5x minus 3y equals 0, and I also know that x is less than or equal to 0. Okay. So again, instead of giving you the point, the ordered pair, right off the bat, I'm giving you the equation of a line. Well, how many points are on a line? Infinite. So there's an infinite number of ways to do this. So you have to get the line graphed first. So if you're going to graph a line, I think the easiest way to do it is to get it y equals form so you can see the slope and the y-intercept. So let's do a little kicking around here and get this to be y equals. So let's take the negative 5x minus 3y equals 0 and get it y equals. So I'm going to add 5x over the other side. So we got negative 3y equals 5x. And I got to divide by negative 3. So again, I like to bring the negatives to the top. See this as negative 5/3 x. So now that you see the line written like this, what can you tell me about this line? Adam.
Slope is negative 5.
Slope is negative 5/3. What's its y-intercept? It'd be 0. It's going through the origin because there's no plus or minus a number here. All right. So we'll graph it. Passes through the origin. And then how do I do a slope of negative 5/3? How much do I rise? How much do I run? Adam.
Go down 5.
Yep, this is negative. So if I go in negative, I'm going to go down 5. 1, 2, 3, 4, 5, and then right 3. What else could I have done besides down 5 and right 3? Caden?
Up 5, right 3.
Up 5, and you're going to want to do both. Up 5, left 3. So we've got 2 points. Well, actually 3 points. Got the origin and then the other 2 points. Well, here's the problem. Is our theta the angle that starts on the x-axis, rotates into the second quadrant and stops? Or is it the one that starts here and rotates down to the fourth quadrant and stops? Which one's our theta? Is it this one? So I make my triangle here, or is it all the way around to here and make my triangle here? How do I know? Adam?
It doesn't matter.
It does matter. Jimmer?
Is it the one below because, the one that's longer because x is less than or equal to 0?
This is telling us which one. Where is x? Think about the x-axis. Where is x? Where are the x values less than 0 at? What does less than 0 mean? Negative. Where is the x-axis negative at? To the left. So this is the one we want. We don't want this one because our x values are all positive over here. So you do have to use this second piece of information. When they're telling me x is less than 0, that happens in quadrants 2 or 3. And my line is in quadrant 2. So that's why I'm going to make it be this triangle here, not this one down here. So again, in order for us to get the 6 trig values, we need a point. Well, we've got the point graphed right here. Its ordered pair is -3 for the x, +5 for the y. And then we got to do a little Pythagoras to get the hypotenuse, the r value. So 3 squared plus 5 squared equals our r squared. So that's 25, and 9 is 34. Square root of 34. And I don't think there's a square number in 34. 2 and 17, yep, that's so square root of 34. So a little more work. Didn't just give you the point, you had to graph the line, and lines are going to go through 2 quadrants. You got to figure out which quadrant it is, and it's the second piece of information that tells you. And so now we're good to go. Now it's easy like we just got done doing. So sine, cosine, tangent, go ahead, fill those 3 in. Sydney, did you get those 3 done yet? Not yet. How about sine? You are correct. You rationalized correctly. Did you get to cosine yet? Okay. Yeah, these take a little bit because you got to hit them with a 1. If anybody wants me to show where that came from, you got to speak up. Don't be shy. So how'd she get that? I'll be glad to show the work. Yes? How'd she get that? Okay, she started out with the y over the r. So she started out with 5 over the square root of 34. She knows she can't leave that, so she hit it with a 1. And now when you multiply, top is just going to stay 5 times the square root of 34. In our shortcut, when you multiply a square root by itself, The square root goes away and you just get the number underneath. See, brave soul back there. That's what we need. Sid, what'd you get for the cosine then? You are correct. Same process. It starts out -3 over square root of 34. Hit it with a 1. And you get the answer she came up with. And then, Sid, for tangent? 5 over -3. Okay. Now the cosecant, secant, and cotangent. Now, I'm going to show you a little trick. You got to be clever here. If you take, remember, sine started out as 5 over square root of 34, then you hit it with a 1 and you got this answer. If you take this final answer and flip it over, what happens? That square root goes back to the bottom and you got to hit it with a 1 again. But if we're clever, if we take the original ratio and flip it over, we don't have to hit it with a 1 because it's just going to be square root of 34 over 5. So you should only have to hit a ratio with a 1 one time. You shouldn't have to do it twice. If you did it twice, that just means you took your final answer, flipped it over, and made more work for yourself. So secant, we're going to flip over the original one and have negative square root of 34 over 3. And then cotangent, -3/5. Okay, with given a line, what to do? When they come up in the homework, just look back at this. You'll know we graphed it, did the slope to get 2 points, and then decide which quadrant, and then go from there. All right, last part. Quadrantal angle. This comes up on the test. It's actually very easy because you've already done it all on your own. But this phrase, quadrantal angles, these are angles whose terminal side lands on an axis. So the angles that land on an axis, well, we start out on an axis, so that makes 0 degrees a quadrantal angle. When's the next time, how many degrees do I turn through before I land on an axis again? 90 is a quadrantal angle. What's the next quadrantal angle? 180. What's the next one? No, you passed over one. What's one's down here? 270. And then finish at 360. Okay, we're going to find all 6 trig values for all of the quadrantal angles, but we're going to put them in a table. Okay, there's 5 quadrantal angles, and we want 6 trig values. So we want 0, 90, 180, 270, and 360. And then we want our 6 ratios. Sine, cosine, tangent, cosecant, secant, cotangent. Okay, anytime we want trig values, we need an ordered pair to work off of. And remember, we get to use any point we want on the terminal side. So because this is left wide open to us, let's use the point that's exactly 1 away on the unit circle. And it's just like the problems you did on your worksheet for today. So we'll start with the 0 degrees. If I pick the point that's exactly 1 away, what is its ordered pair? What's its x value? What's its y value? Adam? 1, 0. And technically our r value is also 1. But now I'm just going to go back and remember, because I got to pick the one that's on the unit circle, cosine's the x, sine's the y, tangent's y over x. So, cosine is the x, sine is the y, tangent is 0 divided by 1. What's 0 divided by 1? 0. Now I've got to flip these over. How do you flip over whole numbers? Well, you pretend there's a 1 underneath them so that they're a fraction. What's going to happen when I flip this over? You're going to get 1 divided by 0. That's undefined. What's 1 divided by 1? And then I'll have 1 divided by 0. Undefined. Did I go too fast? Okay, let's go up to 90. Staying exactly 1 away, what is that ordered pair? 0, 1. Cosine, sine. Cosine 0. Sine is 1. Tangent's going to be y over x, or undefined. Now I flip those 3 answers over. 1 flipped over is still 1. What's 0 flipped over going to be? Undefined, because it's going to be over 1. I get 1 over 0. What happens when you flip undefined over? You're going to go back to 0, because it's going to be 0 divided by 1. Nice. So if you have an undefined and you flip it over, you're at 0. If you have a 0 and you flip it over, you go to undefined. Back and forth. 180. What's our ordered pair there? Negative 1, 0. Cosine, sine, alphabetical order. Cosine's the negative 1, sine is the 0. Tangent's going to be 0 divided by negative 1, which is 0. And then flip those over. We're going to have 2 undefined. What's negative 1 divided by flipped over going to be? Still negative 1. Down at 270, what's your ordered pair? X value is 0, Y value is negative 1. Cosine, sine. Negative 1 divided by 0, the Y divided by X gives us tangent. Undefined. Flip them all over. Negative 1, undefined, 0. And 360, same as 0, because we're going to use the exact same point. Same values as 0. Okay, then they're going to have you use this table to just do some calculations. 4 cosecant of 2 without a calculator plus 3 cosine squared 180. Okay. So all this is asking us to do is take 4 and multiply it by the ratio you get here at 270. So we're going to use the table. 270 cosecant is negative 1. So this is just saying do 4 times negative 1 This, when it's on the trig function, it's asking you to take the cosine of 180, square it, and then multiply by 3. So we're going to look up the cosine of 180, which is -1, and we have to square that value, and then multiply by 3. So just cranking through it now, -4, squaring gives us +1, times 3 is a 3. Final answer, -1. Okay, page 41. 4 and 10. 17 to 24, all you're answering is positive or negative. You don't have to actually find the values, just answer positive or negative is your answer. So you're looking at the ordered pair. Then 27 and 30, and then 34 to 42 even.